if you're still working on the assignment, that's fine. All right, try to finish that up. I do want to allow enough time for me to go over momentum, what momentum looks like. We'll go from there. Okay, momentum. You guys have probably heard that term before. Yeah. Once you start running, you want to keep running, right? You gotta keep going. Or maybe if you don't have momentum, you're just like sitting there. It's just like, oh, I don't have the momentum to stand up and walk around, which I don't. Like it requires work, right? Okay, so momentum is a simple equation. Okay, momentum is actually mass. As a product of mass and velocity. Now, when you look at a product, what's a product in momentum? Or in math? What's product mean? Multiplication. Ooh. Okay, so momentum is equal to mass times velocity. Okay, mass times velocity. That's pretty cool. Now, when we look at this, we're always going to have mass is m, velocity is v. Now, mass took away the m. Mass is m. M is mass, right? So momentum has to be a different letter. So momentum is p. A little confusing, but p, momentum will represent p. Now, when we look at units, what's the unit for mass? Kilograms. What's the unit for velocity?
It's like
Meters per second. What's special about velocity? What's different from velocity than speed?
Oh.
Bubba?
Velocity has a direction.
Direction. Okay, so this has a direction. You guys kind of remember that? Okay, which means momentum, the unit for momentum is kilogram, meter per second with a direction. That all is the unit for momentum. How cool is that?
That's pretty crazy.
Pretty crazy. Right? All right. Now, nailed that. Practice. So when we look at a practice problem, my equation is P is equal to M times V. Now, if I look at this, what is the momentum of a 135 kilogram ostrich? Okay, well, I know it's mass. Running north at 16.2 meters per second. Well, I know it's velocity. All you gotta do, plug it in a calculator, right? Does anybody need a calculator? There you go. Here you are. You good? 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 Yes. Okay, so 135 times 16.2. Has anybody got an answer? 80 what?
87.
87? What's my unit? Kilogram, M over S. North. That's what I'm talking about. And that's how you solve for momentum. Pretty cool. Right? Pretty cool. Check out a second one. Check out a second one. What is the momentum of a 6,000 gram bowling ball moving at 10 meters per second down the alley? Okay. What is the momentum? Try to figure this one out. All right, let's see. Sean, what's my momentum equation? Let's start there.
P equals M times V.
U, n times v. Let's see, Landon. Let's start with my mass. What do you notice about my mass? 6,000 grams. Do I like grams?
No.
I wanted to convert that to kilograms. So gram to kilogram, you got to move your decimal 3 left. Okay, move your decimal 3 to the left. What's my kilograms? 6. Okay. Does that make sense to go from gram to kilogram? Okay. Let's see, Abby, what's my velocity? 10. So what would 6 times 10 be? 60 is your answer. Okay, so 60, my units, kilogram meters over seconds, plus a direction. What's the direction here? Down. It's going down the alley. Or if you just said you rolled it, you folded or rolled it forward. Let's say down the alley. Perfect. Okay. Okay, I feel like starting to pick it up a little bit. Next one. What is the velocity? Oh, this time it's asking for velocity. What is the velocity of a 0.8 kitten? That's pretty light kitten, 0.8 kilograms. 0.8 kilogram kitten with a momentum of 5 kilogram meters per second forward. All right. Try this one. Bless you. Macy, you got an answer? What is it? Ooh, you are exactly correct. Can you walk me through how you did it? So we have our equation. 5 is P. Okay, so 5 is my momentum. 0.8 is my mass. Okay. The opposite of multiply by 0.8, divide by 0.8. So those two cancel. So I'm left with V is equal to 5 divided by 0.8. When you plug that in the calculator, you get 6.25. What's my units? Meters over seconds. Very good. What's my direction? Forward. Forward. Did that make sense, guys? That makes sense? Okay. Let's do a little compare and contrast. Which of these two situations will have more momentum? Which one would have more momentum? A semi-truck traveling at 55 miles per hour or a compact car traveling at 55 miles per hour? Raise your hand. Zach,
A semi-truck.
why do you say that?
It has more weight and power to it.
It has more mass. I like that. Exactly right. Right? Option number 2. Somebody raise your hand. A 5 kilogram bowling ball traveling 8 meters per second, or a 5 kilogram bowling ball traveling at 13 meters per second. John,
The bowling ball tournament, 13 meters a second.
how'd you get that?
Because they're both the same weight, and 13 meters a second is faster than 8 meters a second.
Very good. You're exactly right. This has a faster velocity. Option number 3. Somebody that has an answer. Jared, you got a guess? Well, let's check it out. So what is the momentum here? So when you multiply 50 times 6, what answer did you get? 50 times 300, okay? So that's 300. When you multiplied 100 times 3, 100 times 3? So which one will have more momentum? Or are they the same? They're the exact same. There we go. So those two runners have the exact same momentum. Pretty cool stuff. Okay. Now, when you do like an egg toss, anybody ever done an egg toss before? Love doing egg tosses. What's the strategy when you catch an egg? What do you do?
Catch it like.
Oh, you slide back. Why do you slide back?
Momentum will carry through.
Yeah, so you're decreasing the momentum. You're kind of bringing it back. All right? Now, there's a thing that's called the law of conservation of momentum. And it applies that thought process of why you kind of slide it back. Right? Because you're trying to decrease that momentum. Okay? And the same process. It's kind of like, do you guys remember the conservation of matter? What's the law of conservation of matter? Matter can't be created or destroyed. The same things with momentum. Momentum cannot be created or destroyed. So when we talk about momentum, the initial is always going to equal the final. So whatever momentum. So when you slide back, the final momentum you're trying to decrease, right? Which means the initial momentum would be decreased. One of my favorite examples, not personally, but my favorite mathematical example is a car crash. Okay, car crash. Okay, let's check this out. So before, what should I be driving? Car, truck? Yep.
Cool.
A mini car? Like a smart car or a mini car? A big car. Okay. Yeah, I'm not a good drawer. Okay. Then you got a little thing on the back that says you're cool. Okay. Mini car. It has about, we're going to say, 100 kilograms. How fast are you moving, Zach?
200 miles per hour.
Can we do meters per second?
Yeah.
Yeah. That's still pretty quick. Okay, 300 meters per second. Okay. What else am I driving? What's the second car?
It's an ice cream truck.
Ice cream truck. Absolutely.
We go see him.
Huh.
Look at ice cream going on top.
Trying to picture an ice cream truck. I'm drawing a blank right now.
It kind of
It kind of just looks like
it's
the
it's
yeah, it's kind of like
yeah, like that.
it's like a bus. It looks like an ice cream thing.
Yeah.
There we go.
There's our ice cream truck. All right, let's say our ice cream truck weighs 300 kilograms. I like that. Now, ice cream trucks don't travel that fast. How fast is this one going?
50 meters.
50 meters a second. That's still pretty quick, but I like it. 50 meters per second. Now, after the crash, so that's before. After the crash, we're going to have a different thing. So after the crash, what am I doing on time? Oh, we got plenty of time. After the crash, my car, I'm not going to take as much time, but I do got good. After the crash, the car, let's say, is going to slow down to 150 meters per second. And the ice cream truck, let's say they're traveling, let's see how fast that ice cream truck is traveling. We have to calculate. So we have to calculate it. So when we look at this equation, my initial, so everything that happened before is going to be equal to everything that happened after. Okay? So let's do this in a different color because why not? I'm feeling red. Blue? Red.
Red.
Red. What's my momentum equation? E equals m times v. Okay, hopefully we're starting to get that in our head. So mass times velocity. What is 100 times 300? So 30,000? Is that what somebody said? Okay. What's the momentum of this ice cream truck? Did someone say 1,500?
15,000.
15,000?
Yeah, it's,
15,000.
Okay.
Oh, yeah.
All right. So if you add up all of our before momentum, how much before momentum do we have? 45,000. So my initial momentum was 45,000. Do you kind of see how this problem's coming together?
Yeah.
That has to be equal to all my final momentum. Well, my car, what did my car weigh? 100. And my ice cream truck weighed 300. 300. My goal is to see how fast I'm going. What's the momentum here? $15,000, right? That times that, plus 300 times, I don't know, times some number. We're just going to say v for now. So this has to equal that. Okay, we can do this. 45,000 is equal to that number. So, what's my first step in solving this? Subtracting the two. So instead of a positive 15, the opposites, let's subtract 15,000 on both sides. So those cancel. I'm left with 30,000 is equal to 300 times v. The last step, the opposite of multiplying by 300. Divide by 300 on both sides. So v is equal to, that cancels, 100. So our truck was going 100 meters per second. Well, that's after the crash. So when somebody railed into him, he started speeding up.
Oh,
It's hitting her.
It was a hit and run, right?
Must have lost some of the ice cream.
So, just a heads up of what this week's going to look like. Tomorrow, I got a momentum marble lab we're going to do. And then Friday, we're going to be looking at collisions. Just looking at that same equation. And next week, we'll look at explosions. Okay, explosions apply to the exact same concept. Super cool. And you want to know the best part about all of those?
We're gonna make something explode.
We're gonna watch something.
Make something explode.
No, we're gonna make it.
That's it's kind of hard.
I do have time in Minecraft. You just hop on my house when you're.
I mean, we could hop on Minecraft and do some explosions.
That's right.
There's a Minecraft education.
I'm just kidding. So we'll look at some momentum. It's pretty fascinating stuff, honestly. Cool. All right. Anyway, guys, the rest of the time's yours. We got about 2 minutes left. Is there any questions? When we come tomorrow, we're going to knock this lab out. We'll be good to go.
Sam Johnson, 77.
Yeah, I know, she can just sit there.
It's not even long.
You literally watch a 22-minute video. Who's talking?
Boy,